Hello, my name is James. This is a tutorial about buffer calculations aimed at around A-level standard, towards the end of A-level really. So assumed knowledge here, pH, being able to convert with H plus concentration, also knowing how to calculate pH of a weak acid, just knowing the idea of a buffer that it resists a change in pH, so pH will change a little when you add a little bit of H plus or H minus, and that we can kind of think as this being a buffer solution made from a weak acid and a salt. So this question which I'm going to go through is in three parts. The first is calculating the pH of a buffer, then adding some HCl and calculating the new pH, and then comparing that to the pH of water with a similar amount of HCl. So here's the question: what is the pH of a buffer solution containing 0.1 mole per decimeter cubed ethanoic acid, 0.1 mole per decimeter cubed sodium ethanoate, where the pKa of the ethanoic acid is 4.75? So a weak acid can be represented here. There's some ethanoic acid molecules, and the sodium ethanoate, the salt, is here, and there's the ethanoate ions, and these are in equal concentrations. So you can imagine we put them together, and there we've got our weak acid and the salt, and that's a buffer solution. So we're asked to find the pH. Well, pH is related to the H plus concentration, but apparently there is no H plus. But that, of course, there is a weak acid in there. And acid has got H plus, and that's because our weak acid will dissociate slightly into the salt and H plus, and this will dissociate to an amount proportional to Ka. So we can define Ka as being the concentration as the product over the reactants, and we've actually got some of these values anyway. Ka is given well, not quite in the question. We're given pKa, so that's minus log of Ka is given us 4.75. So that means that Ka is 10 to the minus 4.75. Now, it's an interesting point that this is a small value. Because that's a small value, 10 to the minus 5, that means that this equilibrium actually lies quite a long way to the left. We get quite a lot of this and really not very much of that at all, sort of 1 part in 100,000. So what that means is that we've been given in the question a 0.1 molar concentration of the sodium ethanoate, but when this occurs, and it will occur just a little bit to make a bit of H plus, it won't really change the amount of CH3CaO minus terribly much. And similarly for the ethanoic acid, this was originally 0.1 mole per decimeter cubed, and well, it will have gone down very slightly because of this occurring, because this will have dissociated a little bit into that, but we're really going to say that it's pretty much stayed the same. So that means that we can use the Ka value we're given in the question. We're going to use the concentration of the salt that we're given in the question. We're going to use the concentration of the weak acid that we're given in the question, and then we're just going to rearrange to find out H plus concentration and then pH. So let's work this out. There's just writing out the equilibrium equation again with Ka, which is defined as things on the right over things on the left. Then we're going to multiply both sides by the ethanoic acid, which means Ka ethanoic acid is H plus CH3COO minus. Swap the sides around, we're getting closer to H plus equals H plus, and then multiply by that is equal to Ka CH3COOH. So divide both sides by the CH3COO minus, and there we are, we've rearranged for H plus. H plus is Ka, and then the acid over the salt. So to work out the pH here, we're given the pKa from the question is 4.75, so Ka is 10 to the minus 4.75, and putting into here H plus is equal to, there's the Ka, there is the ethanoic acid concentration, there is the sodium ethanoate concentration, they cancel out, H plus is 10 to the minus 4.75, so the pH is 4.75. What a lot of work to end up where we started, in effect, because this is the same. So this is a general solution that if you've got the same concentration of the weak acid and the salt, then the pH of that buffer solution is the same as the pKa of the weak acid. Okay, I'll stop there and then restart on the next part of the question.